All right, so now in this example, we're looking at the expression 3 times quantity x squared minus x to the third plus 3 times quantity x squared minus x to the second power minus 18x squared minus x. So this is going to run very similar to the last example. First thing we want to notice is that we have an x squared minus x in all three terms. In fact, that we only have one power of x squared minus x in common across all of them, because this is the lowest power of x squared minus x here in the last term. Here we have 3, here we have 2, here we have 1. So the most I can factor out of this is going to be x squared minus x, just one of them. All right, so why don't we start by doing that? So what do I get? I'm going to first factor out an x squared minus x from all three terms. So this gives us x squared minus x times 3x squared minus x squared, because I only took one away from this guy, plus 3x squared minus x, and I had 2 here and I took 1 away, so I'm left with only one of them. So I won't write anything up here, I'll just leave this as is. And lastly, I have 18. I don't have any here. It's not 0, but it's just 1, because I only took 1 away from here. And that's the only one that we had. So I'm left with just a factor of 18. All right, so far so good. So what do we need to worry about at this point? I notice also that this is almost quadratic. We just have this x squared minus x stuff in the first and second terms. But I also notice that I have this factor of 3 out in front of the x squared. In order to use the techniques that we've developed in difficulty 1 and 2, such as just finding two numbers that add to 18 that multiply to 3, we'll need to do a substitution after we factor out this thing of 3, because we don't want this leading 3 in front of the x squared. Okay, but I notice since I have a common factor of 3 in all three terms, I'm going to factor that out. So what does this give me? X squared minus x times 3 times x squared minus x squared, plus I pulled a 3 out of here, so I don't have any left. I have x squared minus x minus 6. Okay, so now this is definitely in a form that I could probably factor directly, especially if you can do the substitution in your head, or you don't need to use a substitution at this point. But we'll do the substitution just for clarity's sake, and we're going to let y equal x squared minus x. So replace the c in x squared minus x, I'm going to replace it with y. So I'll carry this guy along, x squared minus x. You could replace it if you wanted to, but don't have to. Times 3 times the quantity y squared plus y minus 6. Okay, now looking at this, this is definitely in a form that I know how to factor using the finding two factors of minus 6 that add to the 1, the implicit 1 here in front of this y. So what two numbers can we think of that multiply to minus 6 that add to 1? So you could try, well, one of them has to be negative. Both of the factors of negative 6 cannot be negative, because two negative numbers times one another give you a positive number. So one of them needs to be negative. Stick a negative sign here. So let's try factors of 6. 2 and 3 seem to be good bets. So if we did minus 3 and 2, that does give us negative 6. However, when I add them, it gives me minus 1. All right, so that's bad. What if I change the sign to the other one? So that didn't work. Let's try minus 2 times 3. Will that work? That will definitely gives us minus 6 when we multiply. And when I try to add them, that indeed gives me that does give me 1. So we're in good shape. We can factor this now using these two numbers. So carrying everything that I'm not working with at the moment along for the ride, I can factor this as y plus minus 2, or I can just switch the order, y plus 3 and y minus 2. All right, so this is fully factored at this point. However, we have a factorization in terms of y. We have an expression up here only in terms of x. So we're going to have to do a resubstitution with x squared minus x here. Okay, so let's do that. Let's resubstitute in our y. So we have x squared minus x times 3 times, let's keep the brackets here for the time being, x squared minus x plus 3. And then this is going to be x squared minus x minus 2. Okay, so at this point, maybe I can factor this further. Let's see here. I'm still looking at these things. So notice I have a quadratic here and I have a quadratic here. Looking at this, can I find two numbers easily that multiply to 3 that add to minus 1? Off the top of my head, I can't think of any. I'm pretty sure this will not factor, so we're stuck with what we have here. How about this guy? Are there two numbers that multiply to minus 2 that add to minus 1? And the answer, okay, well, let's build another table. So we have blank plus blank gives us minus 1, and then blank times blank gives us minus 2. Well, the factors of 2, or minus 2 rather, could be minus 1 and 2. So let's give that a shot. We have 2 and minus 1. That gives us minus 2. And now when I try to combine this using addition, I only get 1. So our signs probably are wrong here. So this didn't work here. Let's try minus 2 and 1. That gives us minus 2, but when I add them, it also gives me minus 1. So I can actually factor this guy. This factors further. Carry along all the stuff that I have and that I'm not working with actively. X squared minus x plus 3. And now I can factor this thing. This gives us x minus 2 times x plus 1. Close that off. Okay, as I mentioned before, this will not factor any further. And so we have all this stuff being multiplied here. I can remove these brackets because multiplication is associative. All I'm doing is multiplying all these things. So these extra brackets are just extra. Like, they can just be dropped. So remove them. You get x squared minus x times 3 times x squared minus x plus 3 times x minus 2 times x plus 1. All right. Since this guy, again, doesn't factor anymore, we are left with what we got. And this is a very, very long example, and this is how complicated some of these factorizations can be. But the method remained the same. We factored out all the stuff that we had in common across all the terms. We noticed that we had an x squared minus x in all these terms here, so we pulled it out. Similarly, we noticed we had a factor of 3 in all 3 terms, so we factored that out. We did a basic substitution, and then we were able to factor that using the usual method that we have. We ended up getting this after we resubstituted our y is equal to x squared minus x, and then we factored this guy even further to get x minus 2 times x plus 1. We just carried everything else along for the ride. Now we end up with a fully factorized version of this massive expression. So that's it for this example.